Hello everyone, today we are back with a new question. This question was asked to me by my subscriber on my first ever video on my YouTube channel. So let us read the question and let's try to solve. Show that the standard deviation is independent of the change of origin but not the scale. So in my first video I have already shown that the standard deviation is independent of the change in origin. That means if you add or subtract any particular constant value from the data values which are supplied to you, the standard deviation and also the variance will remain constant. So now we are going to show that if we change the scale, what does change of scale mean? First we will see that, and then we will try to show that on changing the scale the standard deviation does not remain constant anymore. So let us see what is change of scale. You must have read in geography that the values of the distance on the map are taken in terms of centimeter, but in the actual ground they represent kilometer. That means we take like this, that 1 centimeter is equal to 2 kilometer. 1 centimeter on the map is equal to 2 kilometer on the actual earth. That means we are multiplying a particular value in order to get the larger value. So whenever we have the term change of scale, it means that we are either multiplying a particular constant value with our data values, or we are dividing a particular constant value with our data values. Let us understand this through a very simple example. I am taking 5 data values, 1, 2, 3, 4 and 5. I'll try to show using these data values what will be the effect of change of scale on the standard deviation. So let us first of all find the sum of all these data values. So 1 plus 2 plus 3 plus 4 plus 5. We will get 15. This is xi, summation of xi. And now if I find the mean, it will be 15 by 5. That will give us 3. Now, if I am now changing the scale, that means I am multiplying all my data values with 2. So now what are the data values which I'll have? I'll have 2 plus 4 plus 6 plus 8 plus 10. So the summation of this will be equal to 30. So what do you observe? Initially it was 15, now it is 30. That means 2 into the old value of summation of xi. Similarly, now if we find the new mean, it will be equal to 30 by 5. That will give us 6. Again you observe that the initial value is 3, but now on changing the scale, I am getting 2 into the old value. So this 2 which we multiplied, that is being observed in the values of summation of xi and also the mean. So this is what will make the standard deviation different. Now let us put these observed values which we have got in the formula for variance and standard deviation. So as we know, variance is equal to summation of xi minus mean whole square by n, where n is the number of data values which we have considered. So the new xi, that means after changing the scale, will be 2xi, like we saw over here. Minus the mean is also 2 into the old mean. So I am writing old mean here. Whole square by n. So now if I take 2 common from both this, and since a square is there, I'll get 4 outside, and I'll have summation of xi minus old mean by n. So this is the variance. Okay, square over here. So standard deviation is equal to square root of variance, which will give me 2 into the old standard deviation. That means only this much. This will remain inside the square root, but this 4, it is coming out of the square root and becoming 2. So what do we find? The standard deviation is not remaining constant. It is rather getting multiplied with the number which we multiplied with our data values. That means whatever you are multiplying or dividing with your data values, that particular constant will be reflected in your value of standard deviation as well. I hope this question has been clear to all of you. For more such videos, please stay tuned with this channel. Thank you so much and have a great day.